So for this problem, to find the fifth term, if the third term is 23 and the seventh term is 1863. So since this problem is a geometric sequence, so using this geometric sequence formula, but observe on this problem, there is no first term or a sub 1. So therefore, we cannot solve this problem using this formula. So we're going to use this formula to solve for this problem. So take note that if there is no given first term, then use this formula for the geometric sequence. And this a sub n is the last term, a sub m, so any terms except the last term, because the last term is a sub n. So for this problem, to solve for the fifth term, so from this formula, so we have a sub n. So since a sub n is the last term, and on this problem, the last term is the seventh term, so this is equal to a sub 7, and the seventh term is 1863. Then to solve for n, since a sub n is equal to a sub 7, therefore n is equal to 7. Then for this a sub m, so a sub m equals the other given term, and that's the third term. So this is a sub 3, and a sub 3 is equal to 23. Then to solve for m, so since m is equal to a sub 3, so therefore m is equal to 3. Then we can solve now the fifth term, but first we need to find this common ratio. So substitute now all the values. For a sub n is equal to 1863, then equals a sub m, that's equal to 23, then times the common ratio, then to the power n is equal to 7, then minus m is equal to 3. Then to simplify, so divide both sides by this number. So divide by 23, divide by 23, then cancel. And this 1863 divided by 23. So we have 1863 divided by 23. So that's equal to 81. So this is 81, then equals. So we have r to the power 7 minus 3, so to the power 4. Then to solve for r, or the common ratio, since the exponent is 4, so we need to multiply this exponent by 1 over 4, and also this 81 raised to 1 over 4 to solve for r. So we have r equals this 81 to the power 1 over 4. So we have 81 then to the power, open parentheses. So you can have 1, then divide by 4. So that's 1 over 4 equals, so 81 to the power 1 over 4 is equal to positive 3. So therefore, the common ratio is equal to positive 3. So since we have now the common ratio, then we can find now the fifth term. So since the third term, or a sub 3, is equal to 23, so therefore the fourth term, so this is equal to the third term times the common ratio, and the third term is 23, then times the common ratio, that's 3. So therefore the fourth term is equal to 69. And then to find now the fifth term, so fifth term is equal to the fourth term times the common ratio, and the fourth term is 69 times the common ratio is 3. So therefore the fifth term, so we have 69 times 3. So that's equal to 207.